our guest of honor today, Austin Griffith. Where do I get started with Austin? He is someone who wears an infinite number of hats. According to his website, www.austingriffith.com, you should check it out. He quotes, builds lots of random things, end quote. And that's certainly not a lie. If you scroll down his website, you'll see that Austin expresses prolific interest in building and supporting many things, from developer tools to an automated beer brewing rig, to being a dad, to running his own YouTube channel, to helping develop Ethereum meta transactions, to releasing his very own art project on one of my personal favorite generative art platforms called ETH Block Art. If you guys like NFTs and generative art in the style of art blocks, definitely go check it out. He's currently at the Ethereum Foundation, where he does all manners of things, including developer onboarding, mentoring, and tooling. So if you're in this meetup and you're considering making the leap of faith into Ethereum development, you are in the right place. This is the meetup for you. Austin is your guy. So without further ado, I'd like to, invite Austin up to the stage officially and kind of take it away. And I will also enable my sharing.
Word, thanks, Tim. That was an in-depth introduction and pretty accurate. Like a lot of people, like my introduction sometimes is is like a patched together thing, but that was very accurate. Word. So thank you for having me. Yeah. And really, like however folks want to ask questions, like I jammed through like a mansplain session of like 1 hour straight this morning, and I can share that link here. So this would be like a super intro, and I'll do an intro now just in case, but that's another one to look through that might be more in depth. It'd be cool here if we could kind of let the group steer and kind of ask questions as we go. I think I'll just show off the tool first, sort of like get right into the middle of the onion of like my work, and then we can kind of like work our way out. But yeah, kind of just discover whatever fun stuff comes along. So let me grab a screen share. Dope. Here we go. Okay. So Scaffold-eth is like a Dapp template, and it like the key piece that I wanted to do is have it so you can make a small change to your smart contract, and then you can yarn deploy, and it's going to move that. It's going to compile and deploy your app to the front end. We'll see more exclamation points show up over here. Does that make sense? So let's just do that again. Let's create like a uint 256 public counter and set it equal to 5. And while we're deploying that and seeing it update, let's just build another function in Solidity here called increment, and we'll make it public, and we'll do counter ++, right? And we saw our counter show up there. You can kind of see these iterations, right? The counter's there. Now, once this compiles and deploys, we should have like a little increment button. See how that shows up? Okay, so this is kind of like the center of the onion here. This tool is a full Dapp template that you install with a couple commands, and everything works out of the box. It has hard hat on the back end, and then it has React on the front end. And it allows you to iterate quickly on your Solidity. Try things out, test your assumptions. When you're like, how do I want to store this? Is it going to be a mapping or a struct or a mapping of struct or an array? And do I want to use a modifier here? All sorts of like in-depth Solidity stuff. This is a good way to test it right here, where you can just paste in your contract, you can import what you need, and then you can tinker with it over here. So let's get to the tinkering part. We don't have any funds right now. If I hit increment, it's going to tell me I don't have any gas, right? So you can grab funds from the faucet with that big annoying call to action, and you should get some funds. And now I can increment that counter. So what's going on here? There's no MetaMask dialogues popping up, right? What's happening when I click this increment button? Well, the theory with local development is you don't need MetaMask to be popping up and be super safe and be like, hey, are you sure you want to confirm this transaction? And a lot of times, if you have MetaMask locally while you're developing, you're going to run into all sorts of problems where every time you start and stop this hard hat node, the nonce of the account is going to reset. You're going to have to get into MetaMask and reset your account. You'll have things where the chain ID isn't right. There's just a ton of like gotchas that I mean, it's really garbage when you start as a Web 2 person. When you start in Web 3 and you start trying to figure out how this works, you just run into problems that it's just like, what the hell? Why is this even a problem? Why am I even dealing with this? And so Scaffold-eth tries to kind of have everything stacked up for you so you don't run into those weird issues. I see Scaffold versus Remix. That's a good shout, because like Remix is totally like, you can paste in some Solidity and tinker with it right in the browser. Scaffold-eth is very, very similar. I had a coding challenge one time where it was me and this other dude. I think it was, I don't know, maybe he was a CTO from Aave or something. Smart dude, very smart dude. And our job was to like build an NFT that had a check-in system with a chain link keeper. And he went to Remix and I went to Scaffold-eth. And he beat me by 15 seconds. It took about 20 or 30 minutes to build the thing. And he beat me by 15 seconds to get it finally in. And so it's comparable, but maybe slightly slower because there's some local build. You know, you have to do a yarn install, and you'll have to do. Let's just look at the install real quick. If I Google Scaffold-eth here, what is that? Why am I seeing? Is that red? Is that red on everybody's screen, or is this just on my screen?
No, I can see red on your screen.
Did I do that? Did I like notate something maybe? I don't know, whatever, who cares? As long as it's not like someone drawing a dick, we're good to go. So Scaffold-eth, basically you do have to do some installation, right? You're gonna have to pull down a repo, you're gonna yarn install, and then yarn chain, yarn start, yarn deploy. So you do have some like local stuff running, and that overhead is gonna cost you maybe 5 or 10 minutes to get all installed and ready to go. So if you really like, I guess if you're testing one thing in Solidity, maybe Remix is going to be faster. And Repl.it, if you guys haven't seen that recently, Repl.it now has Solidity. Let's see, repl.it.com. You can now go, so, and I think you can create one that's Solidity, I think. Yeah. Very excited about that. It's also like this similar setup, but in the browser. And it's like so heartwarming to see some of the things that like Scaffold-eth put together show up in this Repl.it repo. So also, if you're doing quick iterations in the browser, possibly you could also use Repl.it. But Scaffold-eth is a little bit slower, but once you get it up, there's a huge advantage here, and that is that this is tracked locally. I can deploy locally. I can track everything locally. Once it's in the browser, it's kind of a little bit wild and a little bit scary, but also you have this whole front end that's going to come with this, right? And we'll get into the front end and we'll see these components a little bit more, but it's sort of like you start tinkering around, and in that competition, the same way, we both built out the NFT and he beat me by 15 seconds. But all he ended up deploying was the smart contract to get it to work. And I deployed the smart contract right behind him. And then 5 minutes later, I deployed an entire app where people could go to a URL and they could mint the NFT, and it had a front end and it was out on Surge. So there's a slight disadvantage here on time in terms of like getting it out the door quickly, but a huge advantage that you'll have the whole thing locally and you can deploy a front end along with it. Sorry for the huge tangent going into a Remix for Scaffold. Okay, so we're tinkering with our smart contract here. Maybe just maybe for the noobs, maybe I could do a few kind of like intro Solidity things just to show off Solidity as a language. Is anybody? Let me see if I can put it on gallery for a second. Oh, I can only get a few people. Okay, there's not a lot of video here, but is anybody against me doing like a little Solidity intro? If a Solidity intro is good, maybe give me a thumbs up and I'll go from here. All right. No, medium thumbs up. Okay, let's just do a little Solidity.
I asked in chat if you can talk about hard hat a little bit in particular.
Okay.
I'm not very familiar with that.
Also, great shout. Okay, so hard hat, good call. And please like derail me so we can like talk through this stuff for sure. So hard hat is your backend, basically. If we're thinking of this as a Web 2 developer, hard hat is a local blockchain. And it runs like, if you've used Ganache before, it runs like Ganache, where you've got a local node, and every time I make a transaction over here, a transaction happens on my local blockchain and a block is mined. So it's mining a block for every single transaction. And that allows like, you get instantaneous transactions, right? I can make these transactions very quickly.
I'm noticing that's very different is that it looks like you're importing hard hat into your Solidity, which I was never familiar doing with Ganache. What is
okay.
that about?
That is also a great question. This is okay. This is awesome. I love like a more question bit driven. So like I can mansplain for 45 minutes. I think it's okay, but going back and forth like this, I think is a lot more powerful. So this is only so I can do this console log right here. So you really don't need to import hard hat, right? Because hard hat is just compiling, right? So really like this is basically the contract here. And when I've kind of lost some things. When I yarn deploy there, is this thing covering up stuff? Do you guys even see this window? Is it like a weird gray thing, or do you not even see the window moving around? Okay,
no, we
cool.
can see the Visual Studio code. Or
Okay,
dope.
Atom.
Yeah.
Dope. Okay, so yeah, there we go. We took that out, right? So this is just an extra little fun feature, but let's dive into it and use it real quick. So basically when I set the purpose, it's going to do a console log. Right here in Solidity, we're doing a console log. And that's one of the superpowers of Hard Hat. It's built for being more introspective into what's going on. They do stack traces, they do a bunch of, and there's a big plugin community where this is actually Hard Hat Deploy, which is a deployment system built by Wigawag. French dude worked on Mandalas and some other games, but like it's got a good plugin system. But basically like the TLDR is Hard Hat is your blockchain. And also there's 10 accounts that come with that and they're loaded up with cash. So it's also that, remember that call to action I had? Let's see, let's bring up an incognito window, not loogies. We can talk about loogies later, but let me bring up another. So I'm going to go to localhost, but now I'm on incognito. See how I get a different address here? That burner's a little different. Let me close that, bring it up again so we see it. So I'm going to use the Hard Hat account and I'm going to send some money. There we go. That's a nice like pink one, right? When I hit this grab funds from faucet, it basically does this. It takes this address and goes to the faucet and says, send me some funds. You could even click this, pull this wallet up. And this is like the first account of the Hard Hat node. And I can even kind of paste that in there and send myself a whole bunch of money, right? So your Hard Hat node comes with a blockchain that's auto mining blocks every time you make a transaction. Super good for like introspection and figuring out what's going on and getting a console log. Let's go get that console log out of there. So if I do hello.
So is the idea with the console log that it's some kind of syntactic sugar around an event or something like that, and then the Hard Hat node or the Hard Hat CLI is just like filtering on those events and logging them to the console?
That was my question when I first saw this. I think I was talking to Franco from Hard Hat and I said, oh, you guys did a little event trick. And actually I think the way it works out, and I am not a gigabrain, like disclaimer, this is not EDM and I am not a gigabrain. I think what it is actually, since they rebuilt the EVM, they built their own kind of tools for logging in there. So I think it's more at the EVM level, not at the event level. It's a lower level thing that the Hard Hat guys built into Hard Hat.
Cool.
Does that make sense? Nice dog.
Yeah.
So it looks like a Scooby dog.
That's one of my Great Danes. Yeah.
Great Dane. That's what it's called, a Scooby dog. Okay. So we've got our backend, right? This is your Hard Hat node. This allows you to make all your transactions. Because of that Hard Hat node, we have this account here in the bottom left that's like full of money. Let's zoom in on and talk about those burner wallets for a second, right? So you'll notice that I have a wallet in the top right. I can connect in my MetaMask, right? I can connect my MetaMask here. Oh man, typing in a password on, oh man, what are we doing? And then it's just sitting there. What's it doing? Okay, here is a little sugar from Scaffold-eth. Notice that I have localhost selected. So in my front end, which is here, I have the local host network. So you have this target network here. So I have localhost selected. And so everywhere in my app, anytime I click on an address, anytime I do anything network-based, it's going to go to the local host block explorer. If I was on Rinkeby, it'd go to the Rinkeby block explorer. But it also like checks your MetaMask and gives you a nice dialogue that says, yo, you're not on the right one, and even gives you a nice little button. So if I click this, it's going to move my MetaMask over to localhost. So like every single dApp that gets built needs to have that functionality in it. And when I go to a hackathon and I talk to builders and I say, you know, you should use this, it's going to like help you out. There's all this handy stuff. They're like, I don't need it. I want to start from scratch. Eventually, that guy has a user that accidentally spent mainnet money when he meant Rinkeby, or accidentally screwed up and wasn't on mainnet. And then that user has to put in a ticket and eventually add this feature to their dApp. If you use Scaffold-eth, you have that feature out of the box, right? So there's a ton of handy stuff here that'll just get your app deployed quicker. Let's log out of MetaMask. Since we're local, I want to use that burner wallet. I want to just be able to click, and behind the scenes, it uses the private key to sign a transaction, to call that increment function on our smart contract, and it lets me tinker with this increment. Like, okay, what happens if we add a decrement function, right? And that's minus minus, and then we redeploy that thing. What's going to happen on the overflow, right? Testing our assumptions. If it was pre-8, we would get an underflow. Since it's 8.0, we should get safe math built in, so we should get an error, right? But only the best way to test it is right here, right? We deploy it and we click decrement until we get to that 0, and then we click it again, and it tells us that it overflowed, right? And that overflow check fires, right? So much easier than writing a whole test suite. Not as scalable, but this is quick and easy, and it's helping me sort of figure out how I want to write my Solidity. And I was able to just like throw a function in there and go tinker with it, right? Similar to Remix, but then once we deploy, we've got this full app kind of ready to go. So let's take our counter out of here. We kind of get what's going on. The way I recommend you learn, let me just stop there and just add, we'll move on to learning Solidity in a second, but let me see if there's any questions from the room.
What's the story for deploying to a layer 2 kind of thing? Like you showed the mainnet and the test nets can deploy to like Arbitrum or something? Let's
set that as a goal too. Let's deploy something to some weird network. We will do that by the end of this. How about that? Let's just set that as a goal, deploy to some weird network. And we'll get there, but basically it's a selector, right? Same thing that we're selecting there. If we go look at our hard hat config, there's going to be all these different networks. If we want to go local optimism, or we want to go to, I don't even know what Fuji Avalanche is, but someone PR'd it in. If you would like to deploy to Fuji Avalanche, and that's the thing is, I'm an EVM maximalist, right? If this thing is EVM compatible, you basically have to just like PR in your network, and then it's there, and you can deploy to any of these simply by selecting. You can do -- network, or you can select your network here. So there's 2 network selectors. I think we're kind of bouncing around here, but this is where, thinking of the satellite dishes, this is the satellite that deploys. So this deploys your smart contract. And then in the front end, this selects what network you're looking at from your front end. So you would deploy to some public network, and then you'd move your front end to that network. And that's all you have to do to switch networks. A lot of apps have to like carve through and get everything right. As soon as we put this on, let's say Rinkeby, it's not going to be able to find the smart contract, but watch this change from localhost to Rinkeby. And then when I click this, it's going to take me to the Rinkeby block explorer, right? So that one change changes your whole front end. And it allows you to jump from EVM compatible network to EVM compatible network by just changing that one value. So we've got a goal, deploy something to a weird network by the end of this. Are we going till 6 or 6:30? How long should I run here?
It can be up to until 6:30. That's fine.
Okay. Well, we'll see how far we get. Definitely, like when we're setting goals here, I want to like make sure I pace myself correctly. Okay, so let's just do a little dive into Solidity just to get some exposure. And let me show you how I would learn Solidity if you're thinking about learning. So first of all, if you're a Web 2 developer, I recommend that you speed run Ethereum. I'm trying to meme this into existence, but if you Google speed run Ethereum, there is this curriculum that I've put together after like hours and hours of mentorship sessions one-on-one, trying to figure out like, okay, after all these sessions, like how do I scale this thing? Like, what if I had 40 people right now I had to have these sessions with? How would I do it? And I kind of just laid it into a Medium article with a whole bunch of different challenges from a whole bunch of different repos. But let's focus just on learning Solidity for a little bit, right? If you're a decent programmer and you look at the primitives and data types, they all basically look exactly what you think they are. There's, a uint8 is going to be an unsigned integer that uses 8 bits. If we take that thing to 255 and then we try to increment it one more, we'll see that that overflows at 255, right? Because you only have 8 bits to cover it. I'd paste it in and run through it, but I think we got it already with that counter. You guys saw me do an overflow. Signed integers and then bools. Bools are obvious. Addresses are a little bit weird, right? You don't see an address with a hex string like that in a lot of other languages. So let's tinker with that real quick. So I can copy the address from my front end, and let's just set up an address public. We can call it owner. It can be anything arbitrary, but look at that. I'm just going to paste that address right in there, kind of raw, right? But if we deploy that, what we're going to see, hopefully, is this pink and purple guy is now the owner of this contract. There it is. Yeah, see how that worked? So these addresses are sort of like these first class, these primary data types, where an address is like a user or an address is a smart contract, right? And you can do cool things like you can do like owner.balance, and you can do things like owner.transfer, right? So that address is kind of like this object that you can interact with, right? And you can also do, check this out, you can do address this, and that's the address of the smart contract. And then you can do something like balance, right? So this would tell you how much ETH is stored in our contract at any moment, right? Okay, so you've got the primary data types. It's not that hard. Like if you're a programmer, if you can write a for loop in JavaScript, if you can build a to-do list in React, like Solidity is actually like super easy. Building complex smart contract systems, very hard. But putting together a smart contract that does like a to-do list or does a simple token or something like that is actually pretty easy. So we've learned through our primary data types, primitive data types. So just kind of learn through each of these topics, and by going through them and learning, what I mean is like you get in here and you kind of figure out, oh, okay, I'm a programmer, I get what's going on here. There's this storage layer of my map, and then there's some set that lets me set that mapping, right? And then let's see, let's go ahead and save that, and let's deploy it and see if it just works, right? If we just paste blindly, does this work? Okay, cool. So now we have my maps, and then we have a set, right? So if I put my address into this mapping, I get a 0 back. If I say, let's set that to 100, I set it, and then if I go ask for it, it's 100, right? So a mapping is basically a primitive pointing to another primitive. So given any address, there's an integer that goes with that address. And what this is really good for is just like a balance, right? And then we somehow we have this magic function that lets us set people's balance. But let me use this as an example to get into one of the most powerful parts of Solidity, and it's a require statement. It sounds, if you're from JavaScript and you hear require, you think maybe we're like importing something, but it's more like assert. It requires a certain condition, right? And this is really the power of smart contracts, because a smart contract is like a vending machine. It exists on thousands of machines all across the network. It's censorship resistant. It's hella expensive to deploy. It's hella expensive to talk to, but anybody can get to it. Anybody can talk to it at any time. They just need to have a little ether. So think of this as a very public vending machine. So these rules about when you can call what functions are very important, right? And so what we want to say is the message.sender, which is the person entering the function. Like this is just a global variable that everyone knows when they're writing Solidity, message.sender. It's the who, right? So we're going to require that the message.sender equals our owner. Oh no, we don't have an owner anymore. Okay. Oh yeah, we do. Here he is. He's down here. Bring this guy up here. And this is some nasty code. Like I don't even have, like, the tabs are wrong. I don't know. It's gross. But we have a mapping of balance, and we have this set function that lets us set anybody's balance. And then we have this function here that says only the owner can get to this part of the function. So hopefully if we do this right, only the owner, and we'll just say not the owner and not the wanner. And let's just change it. We got all evening. Okay, there we go. Oh, I closed it. Bring that back. Okay, let's go ahead and deploy that. And let's see. So now the way it's set up is not just anyone should be able to set this, right? Let's bring in our bad guy again. I like to have these kind of two players and kind of think of this as like the adversarial person kind of attacking, and think of this as kind of like us, and this is the safe user. But like in the long run, going back to the vending machine model, going back to the massive multiplayer game, like this is everyone, right? We're all jerks. We're all adversarial. We're all trying to take everyone's money. And all we have to trust is this code. And this code allows us all to coordinate, right? Like without this decentralized network allowing us to write this thin layer of code on top of it, we wouldn't be able to iterate and to innovate on top of decentralization as fast. This is kind of a superpower of Ethereum. You're like, okay, let's make it like this. Let's make it like this. Let's take 10% of it and send it to that guy. Let's put it on our price curve and make the price double every time it's purchased. Just like single lines of Solidity create new financial mechanisms. And it allows us to kind of iterate and try those things out. Going down a heady path there. Okay, let's bring it back. Let's bring it back. Okay, so
what do you know who
yeah.
the user is? Like you got a different user when you start up the different incognito window. How did it do that?
Okay, so are you talking about the user in the top right here?
Yeah.
Mm-hmm. So that is basically a burner wallet, and it's generated for you on page load. If I bring up like something awful like Safari and I go to localhost, it's going to give me a different user, right? So every user that lands here is getting a fresh, see how that's pink guy, and this kind of peachy guy, and this is kind of purpley guy. And then if I do like an incognito window and I go to localhost, I'm going to get yet another address, right? And so that's basically a private key in local storage. Don't send a lot of funds to it, right? But it's insanely valuable and easy for local development, right? This dude has $10,000 locally. It's kind of like a third party, but look at that. I just like spun up 4 different users, and now they're all like playing this game, right? Let's check this dude's balance, right? Let's try to set this dude. So this should fail. Here we go. Not the owner, right? None of these 3 should be able to set it, but this dude here is the owner, right? So let's try setting old peachy guys. Set this to 100, right? So we're hooking peachy guy up with 100 balance, and there we go. The transaction worked, right? So now peachy guy, even though he doesn't have any ETH, well, he has enough ETH for gas and stuff. What we're checking is this arbitrary balance in our smart contract, which is just what a token is, right? A token is just a mapping of who owns what, and a transfer function that lets people move it from place to place. And there we go. This dude has 100. I don't know if you guys can see that 100, whatever tokens, whatever. And this dude is like the king, right? He can set it. Okay, now he has 10 set, right? Now if we go back over here and we send, now it's down to 10, right? Oh, that looks weird. Let's see. Reload. Oh, this dude's address here. Check 10. Okay, so all we're doing here is we're keeping track of a balance for everyone, and we're letting the owner set that balance. This is super heavy-handed, right? You really don't want this in production, hardly ever. Do you want some controlling user able to set everyone's balance, right? So normally let's dump that, and let's do something like set the owner's address. So we'll say, let's bring this stuff up here. We're going to say the balance of the owner equals 1,000, and I'm going to say ether here, but that's basically saying times 10 to the power of 18, because the EVM doesn't do floating point math. It needs to be simple. The more simple the EVM, the more decentralized it is. So you basically do this thing where you multiply it by 10 to the 18 to go to Way, or to go to ETH, and then you divide it by 10 to the 18 to go to Way. It's a way to do decimals by shifting everything by a whole shitload. Okay, so let's just save that and deploy that real quick. Right here. And so now this is going to be much more decentralized. So in this, oh, you know what we don't have is a transfer function. We need that, right? How long does it take to build a transfer function? So there's going to be an address 2, and there's going to be a UNT 256 amount, and it's going to be public. So we'll let anybody call it. And what will we do? Well, we'll set the balance of the message.sender. So that's the person entering the function, right? Will minus equal the amount. And then the balance of the to address right? Well, plus equal the amount. And any programmer can look at these 2 lines of code and understand what's going on, right? This is simple code. We're initializing this array sort of and saying that like everybody starts with a balance 0. When we deploy the contract, we set the balance of the owner to 1,000. And then we have this transfer function that lets anybody transfer. But at this point, we can deploy this thing, and it's sufficiently decentralized in a way of like, no one can take anyone else's money, right? Your money, when you have a balance here, the only thing you have to trust is this code right here. You don't have to trust this owner. Now, the owner starts with all the money, and that's true, right? Like I can get this guy's balance and it's 1,000, right? But if I go over here and I get this guy's address and I send this guy, 100 of these, there's no way I can take that back. Not even me can stop that as the deployer of the account. If he checks his balance now, he's got 100 and no one can stop it, right? Like it backs to Ethereum. And that was like a couple simple lines of code to set that up. And that's kind of how ERC20 tokens work. There's more to it. There's an approve pattern. There's some other things that go into the token, but technically that's the heart of building a token, is just setting up a little bit of storage and setting up a little execution that lets you call a function and move some of those tokens from one account to the other. So what we're doing here though, is we're learning how Solidity works. We're going through this speed run and we're learning, okay, now let's look at how structs work, right? Okay, we're going to build a to-do list. We're done building our token now. Let's get that stuff out of here. Let's create a struct for to-dos. Okay, and then let's track some storage, right? So you've got storage elements and then you have execution elements. And then let's set up somewhere, maybe in the constructor, we'll add, I kind of like this one. This is probably my favorite in terms of syntax, the way to do it. And I think you would make it look kind of like that. But there we are creating some new to do. Go get a beer. Okay, and it's completed as false. There we go. So now we're starting to kind of iterate on. So a mapping, going back to that mapping where we had an address that maps to a number, you can't iterate through those. You can ask it at any time, what's the number for this address? And it's going to say this guy's balance is so-and-so. But if you wanted to say, I'm going to loop through everyone and find the highest balance, you can't do that with a mapping. You can do it off chain, right? But you can't do it in Solidity in the smart contract. So if you need to iterate through things, for instance, like a to-do list, that's a good time to use a struct and then basically an array of structs, right? So we set up our struct and then we set up an array of those. And then in our constructor, we add one thing to that. And so if we go here and we look at to do, is it to do 0? Yeah, there we go. Go get a beer. And if we do to do 1, it's probably going to yell at us that it's not, oh, it just doesn't even do anything. I mean, at least it doesn't like explode or something, but that's pretty cool. Like, so we set up a to do and we add it to the list. Once you get into structs and arrays of structs and pushing and pulling from those, you really get deep into like Solidity storage territory. This is like 90% of all the contracts you see. So one of my favorite contracts is the Moloch DAO, and it uses an array of structs for members and then an array of structs for proposals. And so if you want to add a proposal, you're basically pushing a struct of what the proposal is onto this stack. And then as time goes by, time is also very important in smart contracts. As time goes by, a certain one becomes like up for vote or whatever. And you need to be able to iterate through those. So that's where a struct comes in handy. So this is how I propose that you go learn Solidity. Is tell your Web 2 friends, or even you, to go speed run Ethereum, find this, install Scaffold-eth, get it up locally, and then work through these concepts and learn modifiers, events, inheritance, payable, fallback function. But that's just the beginning. That's just the start of it. And then there's going to be this whole tour of duty that you need to go on. And I'm going to pause there and open up for questions, but we'll get back to the tour of duty in a second. So any questions so far, just like anything that comes up, any I don't know, any burning questions?
You mentioned there's like not really looping, even with the structs, but is it like Elixir, like there's recursion that you can do in order to kind of manipulate or like traverse the data?
let's test that, right? Let's see. So let's set up a counter. So let's go back to our counter. So there is definitely looping here, right? And the cool thing is about the way the EVM works is because of the halting problem, it has to charge you for every step. And storage on Ethereum is hella expensive, right? Thinking of the thousands of nodes all across the network, if you want to store something, you're actually storing stuff on every single node on the entire network. So if anybody asks any node, they can get that value. So when you say store this value, that's a very, very expensive operation. But when you say loop through this for loop, that's actually like super cheap. And I'm talking about like 100 points per step versus 10,000 points to write some variable to storage, right? So let's just find out. I think you asked about recursion, right? Let's set the counter to 5. And then should we do it in the constructor? It's kind of wild. Let's set up a function called poke. Okay, and it's going to be public. And we're going to say if counter is greater than 0, we want to do counter minus minus, and then we want to call poke again, right? Is that how we would test recursion? And we might as well just have like a nice little console log that like says poke, right? This is a good little wild experiment. Let's see what happens here. So my guess is that we are going to call this function. Can you believe this compiles on the first try? I love it. My guess is we're going to poke this thing and we're going to see 5 pokes in a row because it's going to recursively call itself until we get it. But let's find out. Here we go. Oh, what happened? Oh yeah, look at that. Poke, 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 poke. So we poked it until it got to that number, and now the counter is 0, right? Let's redeploy that. And this is a little trick here. You have to do -- reset. If you haven't changed anything, this is a little poke in the side from Wigglewog, who made our hard hat deployer plugin. But he does some caching, which is really, really handy on mainnet, where it's like, oh, I accidentally deployed my thing, and then like halfway through I need to add some stuff. Man, I'm glad it's that cached. But locally, it's a pain in the butt. So you start out with 5 with each deployment, and then a single poke takes it all the way to 0. So yes, there's recursion, right? I think we just proved it there, right? That's recursive-ish.
Yeah, pretty close. Yeah, I mean, actually, yeah, that 100% is. Yeah.
Woo!
Yeah.
Cool, awesome. Any other questions about what we've done so far? Just like, even if you feel like you're missing some context, please feel free to. I have not been watching the chat. I should. There's probably some good questions in the chat. Dope. Okay, it's time for the tour of duty. So you sit down and you bang through the syntax, and basically you get to, if I draw it right, you get to the top of the Dunning-Kruger, which is like, I think I can do anything. I understand the syntax of Solidity. I could build a decentralized whatever. And what you do, by the way, and I've been here myself, is you use the thing like a database for a while. you set those structs up. So it's like first name, last name, all that stuff being stored in the contract, right? And you end up using it like we're storing to a database, and each one of like, and it costs you like $500 per transaction, right? With anything you're doing. So at first you use it like a database, that's okay. Tinker with Solidity and get into it, get up that Dunning-Kruger and get basically the license to learn. And then let's go through the tour of duty that's going to kind of like bring you back to earth and teach you what Ethereum is good for, but also what it's not good for and where it's expensive, right? So the first thing I always have folks do is just run through a simple NFT example. This is a fun one because it's like basically all here. It sets you up where it uploads these fantastic pieces of artwork to IPFS, and then it mints them as NFTs, and then you send those NFTs around, kind of like how we have this address, this account here, and this account here. You kind of send them between your burner accounts to make sure it works, and then you could push that up to a public network and eventually deploy it to Rinkeby or whatever. I think it might even go to Rinkeby. That would be cool if it did, because then it would show up in OpenSea. Oh yeah, look at this. Look at this. So you deploy it to OpenSea and have it show up on OpenSea, and then you also verify your contract. So a lot of like little context things that you need to go through in terms of like building Web3 stuff is going to this is going to kind of hold your hand through that and give you something fun to play with, right? then you can kind of like tinker with that and say, okay, if I want to extend that, if I want to fork that, you can take that and take it somewhere else. You can, this next branch works you through, what if the artist only wants to deploy the contract and they want to deploy the contract in a way where someone could come to the contract and pay the gas and mint one of their pieces of artwork. So you deploy the contract with all the artwork in it, but they're not minted yet. And then the buyer pays the gas to mint. And that's just like kind of setting you up for setting the stage for the fact that all of these are just branches of Scaffold-eth. Once you get Scaffold-eth down, there's 250 branches around it for any kind of thing you're trying to get into, whether it's DeFi or NFTs or DAOs or some mix of those or something brand new. There's a ton of branches in Scaffold-eth, and you could just take one off the shelf and move it a little bit farther and then put that back up there, and the build guild will fund you. And we'll get to the build guild. I think developer communities was something that was brought up earlier, and we can kind of get to that too. But back to the speed run. You've got the syntax, you've got the tool, you understand NFTs and sending them around, you've got context for what it takes. Then it's time to take on these challenges. So this first challenge is going back to this idea of you only have to trust the code. It's a network of decentralized and adversarial actors. What you have to build is a staking app. You have to get a bunch of jerks to either coordinate or not coordinate. They can defect or they can coordinate. It's up to you, up to them. But everyone, like no one loses money, basically. Well, let's think of this as a state machine. Think of this as like a little escrow, going back to a vending machine, right? It's a vending machine that anybody can get to. And you set some specific values. You say, we need to get $10,000 together. And we set a date and we say, if we don't have $10,000 by this point, then our state machine turns into a withdraw pattern and people can withdraw from it. If we do get enough together, then that 10K goes on to buy an NFT or do something else. And it just takes it to an external contract. That's just kind of a dumbing contract here. But your job is to write the mechanics of how this staking contract will work. And your job is to write it in a way where, assuming all of these actors are adversarial, they would love to steal each other's money if they could. Even they would love to grief each other if they could, right? You need to build this state machine so no money can be lost, no one can get griefed. There's a specific time period. If we have enough money at that time period, it goes one way. If we don't, then it goes another way. And it's your job to build that out. And you deploy this all the way to an app, and you actually go to a Telegram channel and you turn in your finished app, and someone clicks on it and stakes into it, right? And that's challenge one. So then challenge two is a token vendor. So you'll build an ERC20, you'll build a vendor contract, and you'll sell the ERC20 out of the vendor contract. But the real power here is you'll buy the token back within the vendor contract. And what that teaches you, along with contract to contract interaction, is it also teaches you the approve pattern, how you have to approve in one transaction and then transfer in the second transaction. And you'll get to it. It's a pain in the ass, but you have to work through it, right? You have to get like, why the hell when I go to Uniswap, when I go ETH to DAI, it's one transaction, but when I go DAI to ETH, I have to approve, wait for a freaking transaction to go through, and then hit transfer and then have that go, right? Why does that happen? Well, it's because tokens are smart contracts. They're not moving ETH at the protocol level like ETH works, right? So you'll get into that, you'll learn that. Now, the tour of duty like includes all these weird gotchas, right? Randomness is a good one. I suggest as a third challenge, you either build your own little decks or you build a little dice game and you figure out how to make randomness work. There's a couple ways to do it, either with previous block hash or with a commit reveal pattern or with a VRF oracle. Dive into oracles and learn how that works. Then dive into building a DEX. There's a whole article here that just like takes you through very slowly how a DEX works. And what you'll do is just fork master Scaffold-eth, and you'll get in here and you'll learn how kind of a DEX works. But basically you can like copy and paste code. And you'll say, okay, where's the price function? How does the price work? Okay, I'm learning math, copy and paste that price function, right? And it's just based on the reserves, right? I'm learning how the price works. I'm seeing how slippage works. It's based on reserves. And when the reserves are too heavy on one side, then I'm getting a lot less of that light element. you build your token to ETH and your ETH to token, and you deploy that thing with Scaffold-eth, right? So you can quickly build, this is the whole thing right here, right? This is a decentralized exchange right there, if I could fit it all in one thing. And, you know, thanks to some gigabrains out there for laying this out for us. It's like a perfectly cool, composable open source piece that we could just grab, put into a contract, throw some reserves in there, and now you can swap between that token and ETH right in the contract without ever having anyone that can grief you, and nothing can fall over, right? You're only trusting the code. So then there's kind of like a whole quest of DeFi, right? Learning how lending works. I feel like lending is sort of critical to DeFi. Once you learn how like over collateralized loans work, you learn how to borrow, you learn how to like leverage up, you learn how to short tokens. All of those things are good to learn, but it depends on how degenerate you are. You know, you can decide how far to get into that. Signed messages are super important with Ethereum. So you're using these ECDSA key pairs, right? You have a private key. Your private key can sign a message, and it can go across the network. It can go all over the place. If it gets tampered with, then it falls apart. It doesn't work. But if it comes through correct and you have a message and a signature, you can recover who signed that thing. And that's super powerful, even in off-chain things. I can have you sign a message, and then I can cryptographically verify that you signed a certain message. And those work good for like state channels at first, or like off-chain kind of like signature-based stuff. But what the power really comes down to is that check out the ECDSA library of OpenZeppelin, because basically you can recover in a smart contract someone's signature, right? And that allows you to do all this like kind of meta transaction-y stuff where I sign the intent to move some tokens, but then that message and that signature goes to a relayer, and the relayer puts it on chain. The relayer pays the gas. The relayer is the message.sender. But when you get into the guts of the contract, it unravels that little signed message on chain and says, okay, who actually signed this? Oh, Austin signed this, and he wants to send 5 tokens to Tim. Okay, let's do that. So what that does is it allows me to send Tim 5 tokens without ever paying gas or doing anything on chain, as long as there's some relayer to do that. And Nifty Inc., I'm going to warn you, there's dicks. There's going to be squigglies of dicks. This is somehow a platform for people to draw dicks. But Nifty Inc. Brings in a couple of these. Yeah, there's a couple little ones there. Nifty Inc. brings in a lot of these concepts that we're talking about here. First of all, the burner wallet. If you have a phone or even like a tablet, right? If you have a tablet, point that thing at nifty.inc, you're going to land. Uh-oh, I don't even know. Don't do that. If you land here, you're going to have an address. You're going to be able to try this evening while you're sitting around, or I guess it's like the middle of the night for Tim, but for us that still have time to have a beer after this, go grab a tablet, go to Nifty Inc., click create, and you can draw anything, right? You can draw something here, and this is using this burner wallet. And if I ink this on chain, this is going to use a meta transaction. If I don't have any ETH, so I don't have to know anything about crypto at all, I can land on nifty.inc and it generates me an account. I can make a drawing and it puts it in IPFS. It records it and puts it into an NFT. And then when I hit mint, it's going to mint it on a side chain using a meta transaction relayer. So a lot of this like account abstraction stuff, trying to get us closer to mainstream audiences, this all kind of happens in Nifty Inc., and it's a fun little app to play with. If you go to Nifty Inc. now, there's a blue square that I just drew for some reason, right? It's still updating. But this idea of meta transactions is kind of changing. There's more cool account abstraction stuff, but the idea of meta transactions still kind of works for onboarding. We have to pay the gas. There's kind of some gotchas where like the message.sender is the relayer, so you can't just like replace a contract. But signed messages was the topic I wanted to cover there. You can use signed messages. And then finally, like the final boss is basically build a signature-based multi-sig. So I'd like you to check out Solidity by example and go through some of those topics, and also go through the hacks, learn reentrancy, learn how a honeypot works, where griefing happens, learn how front running works, right? That's going to teach you a lot about the network, but also learn about these applications. And if you look at this multi-sig, we can see that a multi-sig is basically like a DAO, where there's 5 signers, and you have to have at least 3 people vote for a specific transaction to get it to go through. These transactions are all stored on chain. In this instance, I would propose a transaction, or I would propose that we make a transaction, and that would be an actual transaction to the smart contract. So that's 1 transaction. Then someone would confirm that transaction. That's 2. Then someone else would confirm, that's 3. And then at this point, I think we have the 3 out of 5. And then a 4th transaction would have to go in to execute so at least somewhere between 3 and 5 transactions on chain have to happen to make a 3 of 5 work in multi-sig land. And that worked at first, like when Ethereum was like worth $1 or something. But when Ethereum is worth what it's worth now, and you're spending a shitload of gas, you want to think about how you could do as much as you can off chain, but still use cryptography and use those signatures. And that's why the final boss in my speedrun is to build a signature-based multi-sig. It teaches you how to build not just the app, not just the smart contract, but there's a server that holds all these signed messages that helps you aggregate those together. Then it helps you basically make a single transaction and send those aggregated signatures in. So that's a big speed run on just like, here's how you get the critical like starting information. One thing I'll zoom in on, I keep talking about this idea of these vending machines, and I want to make sure the mental model is very clear. Let's talk about a Web 2 developer that wants to make a cron job, right? Let's say you have a compounding interest app that every night at midnight needs someone to poke it, right? It's a cron job. You would think maybe I just need to have a server set up and have that server poke the contract every night at midnight, right? And that would work for a while, but pretty soon your platform starts to spin up. All of a sudden there's $2 million TVL. And then someone realizes you just have this server at this IP address hitting this. Someone griefs that server, the server falls over, and your contract fails to compound that interest that night, and it gets attacked, right? And of course, there's probably a lot more elaborate attacks than that. But a cron job is not just a server checking in. You need to think of it as this is a massive multiplayer game. You need to think of it as there's all these adversarial things. And what you have to do is think about mechanism design, think about incentives. You want to say, if I want this thing to run for sure every night at midnight, I'm going to build a public function that says poke, right? That public poke function that anybody can get into and anybody can call, right? It's publicly available. And then I'll think about my require statements, right? What am I going to require? I'm going to require that it happens once per day. And I'm going to require, I don't know, maybe it's after midnight, something like that. And then the key here is I'm going to send them maybe like 0.1 ETH for doing that. So it can only happen once per day. It has to happen within 24 hours. And if you check in, you get paid 0.1 ETH for doing it. So you build the incentives. You incentivize someone financially to click in and poke that thing. And I guarantee you that thing will get poked every night as long as the gas price is less than whatever the reward is, right? So that's how you build a cron job on Ethereum. And it's good to like think through that kind of like different paradigm of this massive multiplayer game. Okay, last thing we're gonna do here is look through some branches and deploy some stuff, but let me open it up to the floor again if there's questions. Okay. So here's what we're going to do. We're going to make it so we're going to set up a uint 256 price. We're going to set up a price function, okay? And we're going to start it at 0.1 Ether, okay? And to set the purpose, we're going to charge you, right? We're going to make this a payable function that says you have to send money in. And we're going to set up a require statement saying that the message.value must be greater than or equal to the current price, okay? And we're gonna say not enough, okay? And as soon as that happens, we're gonna do something real interesting here. We're gonna say our price equals price times 105 divided by 100, okay? Remember no decimals, so we need to make sure we get our order of operations correct here. But what we're going to do here is we're going to take that price up 5% each time someone sets the purpose. So we had this like weird attestation thing where someone could get in here and set the purpose. That was fun. In 1, 2, 3 lines of code, we set it up so now you have to pay a price, and that price is on a curve and will go up 5% per purchase. Totally different rad mechanism. And all we had to do is add a couple lines of code. This looks good. Let's save it and see if it compiles. Let's see how far we do here. How well we do here. I haven't gotten a single syntax error yet. What is going on here? I'm a terrible programmer. This is working perfectly. Okay, here we go. So now we have a purpose. I can say hello world. You know what? I would like a price function to be public. Oh, look at that. It's not public. Redeploy. Got to remember that. Like, why? Like, I've got this variable here and it's not showing up over here. Got to be public. Let's do that again. Now, hopefully we can see the price, because it's going to be a lot easier if we can see the price in the front end so we can work through this. All right, there we go. So now if someone pays 0.001, and by the way, this is some shitty UI here. This is for a developer. I'm going to make them hit this little green button and take it to way, right? Now, when you build your app, you'll have a nice little app and you won't do this. But at first, when we're poking at it, it makes a lot of sense to just make this very raw and sort of like I can just follow this. And oh no, do I not have enough money? Oh, I don't have enough money. Okay, we got to give this homie some money. Here we go. Boop, 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 boop. There we go. Okay, now look at the price. The price is up now, right? So now if I try to pay that same amount again, it's going to fail. Not enough. I've got to pay this price now, right? Boop, boop. Okay, all right. So we've got our app. This is what it's going to be. This is what we're going to deploy. We made a message board on a price curve. Oh, you know what? There's an issue here where the contract is making a bunch of money, right? So that's cool, whatever. The contract is making money. Let's send that somewhere, right? Should we send it to Vitalik? That might be kind of funny. So let's do that. All right. So what's Vitalik's ENS address? Look at that. Isn't that nice that I could just type in vitalik.eth and get ENS resolution right in my app, right out of the box? That's what you'll get with Scaffold-eth. Okay, except for I didn't copy it in time. Let's go to Etherscan and get it. Okay, what we're gonna do is we're gonna send this money to Vitalik each time. That's a bad example. Let's send it to the build guild instead. Let's send it to public goods, right? We're raising money for public goods. We're gonna send it to the build guild multi-sig, okay? All right, and I'll get to the build guild in a second if we have time, but so I'm gonna set up this address, public. It's probably immutable or constant maybe. Biddle giddle is equal to that. Let's see, does it like that? Is it even okay with that? My cat's snoring over there. Hopefully that's not picked up too much on the audio. Okay, so there we go. We've got biddle giddle. So what we want to do here is we want to send some money to biddle giddle. Now, we can, you want to do this at the very end to avoid reentrancy. Anytime you're going out, you need to make sure all of your state changes are done first, and you finally do, and go look at reentrancy. It's super fascinating. But we're going to say build guild dot transfer the message dot value. Now this would basically send the money that came in to the build guild. And that's pretty straightforward. But this doesn't work because the build guild is a multi-sig. It's going to use a little bit of gas. A dot transfer doesn't work. What you need to do is dot call to send ETH Solidity by example. Wow, I got a lot of stuff wrong there, but I still bet I find what I need. Okay, what I'm looking for is this. There's this line right here. This is what I'm looking for. So I'm going to replace all of this with this line of code that I just know works, and it's what everybody uses, and it's another gotcha in Ethereum. But if you want to send value to the build guild, you do a dot call, and then you bring in this value here. See that? And then this is call data. It's blank and fails to send ether. All right, this looks good. Let's see if this ships. So we don't want any money to stay in the contract. We basically want to set it up so we're selling this on a price curve, and all the money goes to public goods. Nothing lands in this contract. Good to go. It's ready to go. Let's tinker with it. Let's try like maybe one time. Make sure the 0.1 goes through, and make sure no money stays in the contract. And we can even check this dude's balance. Check this out. We could do yarn balance this dude, and there we go. 0.1 ETH, right? I can zoom way in. It's 0.1 ETH. Okay. So we've got our app ready to go. it's time to go to production. It's time to deploy this thing. Let's say it works. Maybe we tinker around and we make a front end. If you get into the app, there's a ton of like example UI things, like here's how you make a button that calls a function. Here's how you make a button that sends value. I have all these components here. Here's how you listen to events. Here's how you set up your UI. So there's just like a lot of copy and pastable examples. Let's pretend like we spent a little bit more time on our UI, because kind of, let's be honest, the blockchain stuff is the most important thing. React developers are a dime a dozen. Web3 developers are the smart ones, right? That's a JK. Like any Web2 developer can get into Web3 with this speed run, right? But anyways, let's deploy this app, right? Where are we going? What is the weird network we want? I promised we would deploy to a weird network. Let's see. Let's find one here. I mean, I don't have a ton of some of these. Like having to go get local Arbitrum might be bad. Like, can we just do Goerli and pretend like it's an exotic
don't do
EVM
this just
network
on my account. Like I asked for this, but seriously, I just wanted to know like how easy that was, and it looks like it's pretty easy.
Super easy, right? Let's just pick Goerli. I'm just picking a random EVM network, right? The network just needs to be we need an Infura endpoint basically so we can push to it, and we need some funds, right? So let's actually, I'm going to go with Kovan because it's quicker. We're pushing up on time here, not Kovan optimism, but just like straight up Kovan. There we go. Let's just go with Kovan. Okay, so if I do a yarn deploy and I do -- network, you probably can't see that. Let's make that bigger. -- network equals, and let's go Kovan. This is going to fail, I think, because I don't have any Kovan ETH. It should tell me that, yep, you don't have any money. Wow, that's a classic Web3 error right there. Instead of saying you don't have any money, you get hit with this wall of text. Really what you need to see is insufficient funds, dude. But you get all of this instead. So insufficient funds, we need to send some money. So the way it works is we don't have these nice deployer accounts like we had while we're working on our local hard hat node, right? We need to do a yarn generate. And this is all in the README in the repo. But what this does is create a local mnemonic. Now we have an address. If I do yarn account, it's going to give me that address. Let me see if I have some Goerli on a burner wallet. That would be super cool. So I'm going to open up a Punk wallet. Check out this Punk. Oh, that is a cool Punk wallet. So it's got like a little zombie Punk. So if you go to punkwallet.io, it uses Scaffold-eth to make you a wallet. And then I'm going to select Goerli. Let's see if I have, Kovan, right? Yeah, Kovan. And I'm going to go to that QR code and I'm going to hit scan. I'm going to scan that QR code. Okay, so now it's telling me I'm sending to that person. Let's just send like 0.1 Kovan and go. All right, in 5 seconds, that dude should have some Kovan. Now, if we do a yarn deploy network Kovan, I think this is going to go to Kovan. Let's find out. Please work first try. Oh yeah, we got a transaction hash. That's always a good sign. There we go. It's deployed. All right. So now we have to change, going back to those two satellites. We changed the first satellite. Both of them were pointed to localhost, right? We pointed the first satellite at Kovan and we fired the contract. Now we need to go to the front end and change it to point at Kovan too. So if we go to the app and we can watch this happen, right? If I'm over on localhost, it's still my localhost contract. But if I go here and I type in Kovan and I hit save, now the whole app shifts over to be on Kovan. And anytime I click on this contract address, so there's the address of the contract on Kovan. If I click this, it's going to take me to the Kovan Etherscan. And here's the contract and I can verify it or whatever, right? So there's our app on Kovan. Now we're almost there. What we need to do is a yarn build. We need to build the static app, right? Technically, this is a decentralized app. It's out there. If we verified our contract, it'd be a lot easier, but anyone can interface with that contract at this point. That it is deployed, it is out there, it is decentralized. Anyone can get in there and pay the current price and set the purpose. Let's just try that. Now is the time to connect my MetaMask, right? I'm gonna bring my MetaMask in. I'm gonna switch it over to Kovan. I think I'm kind of a Kovan whale. Let's see. It's taken it kind of a long time. I feel like the Infura key, I should zoom in on that. Your Infura key. So Scaffold-eth comes with like this sort of God mode Infura key, but the way it works is it can't load very much. So depending on what URL you're coming from, as soon as you go to production, it will fall over immediately. But it's built to work for as many people as it can out of the box from the start. So your app is sort of like, you can prototype pretty quickly with this God mode thing, but as soon as you're going to get users, you need to take it off this Infura key or your whole app will fall over. But I think that's what took so long there. Okay. Hello world, we're ready to do this on chain. Here we go. And we need to pay 0.001. Now, if someone gets to this before me, like if someone hit this contract before I could get to it, you guys could be griefing me right now. And basically they could be paying the 0.01 ahead of me. Whoa, there's something weird going on here. Why isn't that button working? Oh, what? MetaMask? Man, there's so many things wrong with MetaMask. There's so many reasons why Web3 developers rage quit, because when it doesn't work, then they think there's something wrong and things are so complicated. I want to start over. I just want to flip my desk over right now in MetaMask. Okay, I'm going to click the button again. There we go. There's our MetaMask prompt. Are you willing to pay 1.1? Make sure we're on Covan. Send that baby. And you'll notice now that we get these nice notified JS. Instead of the kind of placeholder notifications, we get nice notifications. That comes out of the box with Scaffold-eth from Block Native. Now the price is up. If anybody was watching this, they would be able to see this. Okay, so let's deploy this thing. Deploy the app, right? We've deployed the contract. We've built our app. I'm going to do a Yarn. I could do Yarn IPFS, Yarn S3. My favorite is Yarn Surge. And this is going to be Coven Perp, maybe. Let's see if this works. I might have already used this one. This is a demo I do sometimes. Let's see, Covan Perp. Are you happy with Covan Perp? Ooh, it's uploading. Okay, so now you guys, let me see if I can send this to chat. Man, I have not been paying attention to chat. Hopefully, there's nothing there. That's nothing there. Okay, so Covan Perp.surge.sh. It's only at 10% right now. It's slowly updating, but once this goes, we will have basically built and deployed a smart contract, tinkered with it, and thanks to that front end that was already there, now we can just deploy that front end and anyone can get in and start paying the price. And you can set the purpose to whatever you want, even something gross, but don't do it because it's on my screen right now. Yeah, I guess we're at only 23%. So we're waiting for this to upload still. Man, this is super slow. I wonder if that's my internet or what. Okay, open to questions. We'll close. I'll close with build, guild, and branches, but let's open it up for questions and see just like if you guys have anything to talk about.
Is it normal to build like production UIs using Scaffold-eth? Like you've demoed this super cool development UI, but is it normal to take this and turn it into a real production thing and use that?
Yep, exactly. And that's what you want to do. You don't want to use this contract component. You want to carve this contract component out. You want to set up an input box. You want to make sure that input box is controlled. As they change it, it updates some state variable, right? And then when they hit send, it looks at the price. It initiates the transaction to send the current price with the text that they put in their text box. It takes it to weigh automatically, right? But that, like, I could write that front end in 10 minutes and it would work. And basically I would carve that stuff out and just make that a nice, pretty front end. But I'll let the React developers do that. But really that example UI really shows you how to do that, right? Let's just look at, so here is a button. So we were setting the purpose earlier, right? There's a button that sets the purpose. There's a button that sends some value. Here is the transaction we would use. We would basically just copy and paste this. We'd go to our contract, .your contract, and we call the function, what's our function called? Oh, it is set purpose. We'd set the purpose and we'd pay some amount, right? So you'd probably want to do one await here, and you'd want to get the like let price equal await, and you do read contracts .your contract is it price? I think it's that right there. And then you would put the price in here. So like one little thing, but basically if I put this into React, that would do what we want it to do, right? So yes, you would probably not. Oh, what did I just quit? Is everybody still here? I just quit something randomly up in my bar. As long as everybody's still here,
we're still here.
I'm
We're
gonna
still
keep
here.
going. Okay, but hopefully that makes sense. You definitely want to build a React app and not use this, but this works fine for like just getting this app up here and getting it so we can all tinker with it. Like say you had to deploy something like loot just came out and you wrote a quick little app that like looks through and finds the next loot available and mints it for someone. Like that UI could be ugly as hell as long as it's up there and it's a button for someone to push. Now, making UI perfect, making UX perfect, that's like you know, it can take forever, right? So it's up to you on how you build your UI. But now let's see where we're at with this Coven perp thing. You guys should be able to go to covenperp.surge. You should get this Ethereum app. You should be able to, you'll get a burner wallet, right? But ignore the burner wallet and just connect in with MetaMask or some other wallet. If you're not on Covan, it'll notice that, it'll help you switch. Then you can say, hey, and now you need to do this value and multiply it by that and send. And if I beat all you guys to it, someone might beat me to it. And then that might, like we'll have collisions, right? Like if we both go at the same time, only one of us will get in on the block, depending on who set the higher gas price. But there you go. And if you guys hit this little refresh button or you refresh your page, you'll get the latest purpose. So we basically built a decentralized app, right? Like this is going to continue to work. Not even we can stop it, right? I deployed this thing and now I can't stop it. And it's going to do exactly what it's coded to do. It's going to let you set that little variable. It's going to let you set that purpose variable. It's going to make sure you paid the right amount of money. It's going to increase the price by 5%. It's going to set the purpose. And then it's going to send all that money over to the build guild address. So if we check the build guild on Covan, let's see, how do we do that? Right here. Oops, that didn't go to, oh, weird. That should. Okay, let's do Covan. Etherscan. This dude should, there we go. He has 0.205 ETH, right? So the money is flowing into the account we wanted it to go into. Okay, any other questions there before we close this out? Okay, and feel free to, no one's said it yet, but feel free to go to Coven Perp and set that up. Okay, so there's a couple different paths you can go down. If you're a developer and you're just thinking, I just want to work at a Web3 shop, get through that speed run. Just get through a few challenges. If you get through challenge 3, you've built a DEX, hit me up in the DMs and say, I want to go work at a Web3 place. Here's all my challenges. I'll tell you to post them up publicly and have people poke at them. But basically, like I can connect you to a bunch of places, including ChainSafe now, right? Like these are now all connections I have where I can send developers. So if you want to go work somewhere, the bare minimum is getting through those 3 challenges so you have some sort of a Web3 resume, right? Now, if you want to build your own project, that's kind of the bread and butter of Scaffold-eth. But then if you want to go even higher level and you want to basically be an EVM auditor and you want to really get into things, start with the Solidity by example, go through all the attacks and understand the attacks. There we go, chainsafe.io/careers. Way to go. Perfect plug. Yeah. So if you want to get into auditing, I would look at all the audits first of all, but then go look at the Ethernaut. This is where I tell folks to get started who want to really dive into EVM stuff and understand kind of what's going on beneath the sheets. You get to reentrancy at 10 and there's 25 of them, right? So you're going to learn a lot of stuff. The King of the Hill is about griefing, I think, where like you set it up so it sends money out. Yeah, see, king.transfer. So to be able to take over, you do a king.transfer. And today we learned if you transfer to an address that has a fallback that burns a little gas, this will fail. So someone tries to do this and then they're going to be blocked out forever. And all you have to do is set up a contract to do that, right? So if you want to get into auditing, get into Ethernet now. So coming back to kind of the middle of the bell curve, if you want to just build your own product, you want to just build something, you're an entrepreneur, you're a builder, you're getting into it, go through the speed run, but then get on Scaffold-eth and start looking through the branches, right? Start looking at maybe like an NFT example, right? And I'll get into some of these NFTs in a second, but like there's so many NFTs here. The one I want to show off is just something I'm super excited about is the Loogie SBG. And we'll get to that in a second. Once you go through the branches, you find something that's close to what you want. everything is going to be structured exactly like you're used to with Scaffold-eth. The front end is exactly the same. The contracts are all in the same place. All of the commands are the same, but there's 250 different flavors of it, right? And that helps you like get to having a prototype or a product quickly. The build guild is the second place to look for a prototype to fork. So I have a handful of just like, so basically the build guild is a public good on Ethereum. It's a bunch of developers that are affiliated with me, that are sort of mentored by me, that are building whatever, products, prototypes, tutorials, any kind of generic products that the ecosystem needs. Let me find a good example, like a simple stream. It's kind of like Sablier, but this simple stream sets it up so the dynamic is a little different, where someone has to withdraw from it. Say you want to stream funds to someone but have them withdraw the funds, or R tokens, where you want to invest something and then the yield comes back and you split the yield and you redirect the yield to one place and you send the principal somewhere else, right? Or an NFT auction or an NFT viewer. Or a lending app, or there's just so many stuff here, proxies and apps and swappers and attacks. And these are just like fun examples also. These are just branches of Scaffold-eth. So the final thing I want to get into is just because it's like super fun and interesting is these loogies. So look at this. Let me get into the loogie NFT. So the loogies, first of all, let me go to OpenSea and show my bags real quick. If you go to loogies, V2, there are something like 7,000, or maybe it's only 18, almost 2,000 of them. And they're these little homies right here. So basically they're a different width and they're a different color, right? See how they kind of vary in color and width. So normally an NFT is just an entry in IPFS. It's something someone has drawn, uploaded to IPFS, got the hash for, and then put that into the token. These are different, and I didn't invent this. Someone else invented it. I just am making it really easy to get to, or to reproduce. But let's keep those loogies over here. Let's go look at, if we go to packages, we go to hard hat, we go to contracts. Here's our collectible right here. So here is the loogie. And look at this. So check this out. So this is an SVG. So here is the I. So that's I1, which is back here. And then it renders the body, right, which is this body right here, and then it renders the second eye on top of that. So this is Solidity, and it's drawing an SVG. And what's really cool about that is this chubbiness is a variable within the smart contract itself. Each of these NFTs has a chubbiness on chain and a color on chain. So what you could do is kind of breed them together and mix the colors, mix the chubbiness, right? There's a lot of fun things you can do with that SVG. And then that renders the JSON there too. So the really fun thing I want to show is, let's see if I can find the link to this. Oh man, I don't even know where it is. Let me see if I can find, maybe it's deployed here. Sending ether, it might be this right here. What does this go to? Nope, that is not it. Oh, here we go. Loogie tank video. This is my like, I'm on the run and someone asks me for something. I go to my own website that I set up. Okay, so check this out. Check this out. So you can see here, we set up these new NFTs that own other NFTs. So this is a composable SVG NFT that is a tank, like a fish tank, and it's an NFT itself. And you send loogies into the tank. And what's really interesting here is we make sure that loogie render function is public. So when I send it in here, the parent is actually looping through its inventory and calling the render function of each of its children and amassing this large SVG and then displaying it. So this is what it looks like in OpenSea, basically rendering a tank of NFTs. And then we added animation, and it's like deterministic animation based on the block hash. And so this is just an NFT. I could put this on OpenSea. I could fractionalize it. It sticks to the standard. So the composability of these like SVG NFTs are really exciting, and I just wanted to show those off. But I think that's the end. Go. Don't go buy some loogies. How do I not pump my bags? Don't go buy some loogies. But some neat fun things are to come with loogies too. Yes, you could have a tank of tanks. Imagine you have a wall of tanks, right? And it just puts all the tanks on like a wall, like it's a fish shop wall, like a fish store wall. And then you have all those loogies moving around. And even like, so the loogies are dynamically generated, right? So say a loogie gets sick and he turns red. You would see that live within the rendering of the thing. And that's happening in the smart contract of the loogie, not the smart contract of the tank. So lots of fun stuff there. I'm gonna kick my share off. I think we've gotten to time here. I kind of went over a little bit. Hopefully that's a lot of fun stuff. Any closing questions or comments?
Yeah, if anyone has any questions, feel free to unmute yourself and ask.